on the Holothuroidea, which are going to be the sea cucumbers. And let's go look at our video selections over here. Holothuroidea, here's a little general thing of some just absolutely beautiful ones. I like these Vimeo ones. They're very artistic looking. These are some down in deep water. There are these things called sea pigs, and there are a couple of kinds of holothurians that will actually swim along. So they'll be pelagic in the sense that they're actually in the water column and they don't necessarily ever settle down on the ground as part of their life cycle, or at least not for any length of time. The sea pig is fascinating. You've definitely got to see it. They are, again, just a sea cucumber, but they've modified some of their tube feet into these things that look like little pink legs. And they use them to walk along, and then they have these little hydraulic arms that are constantly pounding food into their mouths. And that's what you see over and over again with these sea cucumbers. And there's symbiosis. I believe that's the one with the sea cucumber that has a little fish that lives in its anus, essentially. And the fish can benefit because the anus of a sea cucumber is used. Sometimes it'll excrete its intestines if it's threatened. And that's what you're going to see down here. It's evacuating its bowels. Oh, actually, no, that's pooping, I think. But in one of these videos, maybe the top, no, I don't know. It's the one from National Geographic. You're going to see them, spitting out their intestines, which are quite poisonous to other animals. And this is a way that they can say, stay back. It's like the world's worst case of hemorrhoids, maybe. But it works for the sea cucumber. And they can regrow their intestines because, of course, they're echinoderms. They can regrow whatever they need to regrow. And then these are pictures of echinoderms eating and eating and eating and eating. Yeah, it never stops. When I visited Alaska fairly recently, there were sea cucumbers down the floor all over the place. And you could see them working those 5 little branchy arms and just one at a time, pop, 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 going straight into the mouth. Yeah, that's just what they do all day long. They are little eating machines, eating and hiding. The two things they do best. So let's look at these couple of slides that we've got here. So what is a holothurian? Well, it's essentially the same as an echinoid. Except in this one, we're imagining, what if you hooked a tugboat up to both ends of this thing and just yanked it? So mouth at one end, anus at the other end, one of those regular echinoids, and just pull it apart, stretch it into a long tube. Then what you would have would be, you'd have the ambulacral zones on the side and interambulacral zones here. And bam, that is basically, with a mouth at one end and an anus at the other end, modify some tube feet so that they are now for feeding food into that mouth, and you have got yourself a beautiful holothurian sea cucumber. So fantastic. Look at them. And so these things are going to be literally tube feet. And in the genetic sort of stretching out process, remember, they don't fully develop their skeleton. We see a lot of more extensive skeleton development in all the other groups of the Echinodermata. And the skeleton remains in almost an embryonic state in the Holothuroidea. It's just going to be little tiny ossicles floating around just underneath the surface here. And they retain all the muscles. So they are like a big muscular tongue that can move around and contract in many different ways. But they just don't have the bones. It's like a tongue without bones. Yeah, fantastic. Okay, here are some of these little ossicles, and look at them. Look how wonderful they are. Look at these little shapes. There are some that look like little fish hooks. Here's some fish hook ones. Some little wagon wheels, some that look like little sheriff stars from the Old West, and some that are pointy, spiky, have little bases and spines like little clubs. All these cool things, and they all just float around inside the flesh for the most part. There are some where you'll get a little rough projection on the surface where they'll poke out the epidermis a little bit. But for the most part, yeah, those dermal ossicles are going to be right in here between the epidermis and the circular muscle, floating around in this sort of area, kind of unconnected to the world. And we bought in a bunch of sea cucumbers so that you could dissect these. And the idea was to be able to look through these and actually see those ossicles, see how the organs are put together, see how tube feet work, and how the little ampullae look on the inside of them. And yeah, they're essentially the same as in any other echinoderm. It's just a very, what we call a pedomorph version, where you have something that is going back and just kind of stopping at an early developmental stage for a long time, and then going off in a different direction from that stage. So this is something that we see humans, you could say, are a pedomorph version of other great apes. We develop very similarly, human babies and, for example, chimpanzee babies, up to the point when they're both about 6 months old. And then the chimpanzee just stops and gets big and strong and learns to fight on its own and, yeah, go out and hunt food. And human babies just take forever. They keep developing and they learn to walk and talk really slowly. But during that time, they're building up this social complexity and linguistic complexity. And yeah, we're similar. The idea is we're similar at a certain age. It's just that humans keep going in one direction and other apes go in other directions. And it's the same thing here with holothurians. So here is the internal anatomy of one of these beautiful, beautiful guys. Once again, you've got your water vascular system shown here in blue. You've got your little ring canal running around the center exactly as you would imagine. Running right around that is going to be a nerve ring. So they're going to again have that ring brain that's going to go around and 5 branches that are going to run up the 5 sides. Here are the 5 ambulacral grooves, and you see underneath each one of these you're going to have little ampullae that will extend and operate the tube feet. Now, holothurians in some cases will actually have sides of their body where they don't really express the tube feet. And so through evolution, they've actually lost some of them. But in things like the sea pig, they're going to have gigantic tube feet on one side and very tiny tube feet on the other. But if you were to rotate this thing around, you should be able to find an axis of almost 5-fold symmetry, 5 little rows that used to be the ambulacra and still have the tube feet. So it's a highly modified version, a kind of a primitive version, but still very reminiscent of what we see in the other groups. And so at this particular stage right here with the anus at one end, the mouth up there, and a little bit of 5-fold symmetry, this resembles very closely, I think, that early embryonic development stage of the echinoid that we saw in the first group of slides where we were just looking at these for the first time. So yeah, it's like they never grow old. They just grow weird. Okay, here are some of those little larvae again. And so you can see there's our little crinoid Doliolaria larva. Here are some of the other ones. And the holothurian stops at this sort of bipinnaria stage. And we call it an auricularia. Auricle is like an ear. And so we say it's like a little ear-shaped embryo. And instead of developing these long, sort of floppy, ciliated arms like in a starfish or a brittle star or even an echinoid, they got the arms with skeleton on the inside of them, they're going to keep this original shape from way back in starfish times and expand differently on that theme, go through a different sort of metamorphosis, but from stopping at an early stage. And so here is one of our little larvae, and you can see once again the little ciliary bands. Here's our little anus, and the mouth's going to be in here, I believe. And yeah, lots of little ciliary bands, and so this thing has a lot of freedom of movement and feeding. And if you were to dissect this little embryo, which would be very difficult, but you could do it, you would see that along the top in this little groove, this is where we have the tube feet. And so the tube feet are eventually going to be feeding food into the mouth. And then down here at the bottom, we have what is going to become the ring brain. And so it's still a blob brain in this because they haven't really developed that. But as the coelomic canals, basically the intestines, if you like, develop, they're actually going to sort of push through the middle of the brain, and the rest of the brain is just going to move aside to accommodate this. And so these arms here, that branch off the brain, are going to be equivalent to the arms, the nerve bundles, rather, that run down each of the arms of a starfish later on, or run down the 5 axes of symmetry on a sea cucumber later on in its life. And so there we go. It starts out bilateral, just as we said, going through these early developmental stages, and then, yeah, and then doing its own thing. So that kind of tells you where they came from, where they're going, and how they got there, all in one little embryological picture, which I think is really nice. So that's the end of the sea cucumbers. There is very much more that you could learn about these wonderful, fascinating creatures. But this is kind of an overview course. We want to get a little bit of everything. And so we can't go too deep into anything. But boy, do I think echinoderms are fascinating. Yeah, love to be able to do a bigger course on these one of these days. Anyhow, that's all we've got for echinoderms this time. Thank you very much.